Hello, welcome everybody to this new Pix4D webinar. My name is Oliver Kung. I'm one of the co-founders of Pix4D, and today's webinar is going to be about quality control. So basically how to assess quality, how to make sure that the project you do have the required accuracy, and how to assess that. But first, before talking about accuracy, it's probably best to start about quality. It's very linked usually to accuracy. And we'll first talk a little bit about what type of accuracy you should expect in your project. And just before talking about accuracy, it's extremely linked to GSD. So let's first quickly define what is ground sampling distance. So the ground sampling distance is a very important notion, and this is basically the average size of a pixel on the ground. So imagine you take a camera and you shoot a picture. Then if you look at the one single pixel in your camera and you look on the ground and you start measuring how big it is, this is basically the ground sampling distance. And if you do that for all the pixels of all your images on the 3D model and you measure the size of them and you make an average, this is what we call the average ground sampling distance. So this value, this what I will call GSD. This GSD depends on many different parameters, but the most emblematic parameters on which it depends is basically the altitude, meaning the difference of distance between the ground and the place where the camera is. Of course, it also depends on other parameters such as the focal length, the type of camera, and so on, the angle of the camera, and many things like that. But let's say by default, usually the main vector on which you can do a difference on your GSD is how close is your camera to your object. And at low altitude, as an example, so something, let's say, like at 50-meter altitude, so at 50-meter difference between the object and the camera, very often with a normal, let's say, 20-megapixel camera and normal lens, you will have something that each pixel is approximately 2 centimeters. If you go much further away, like for example at 100 meters altitude, then usually you should expect something more like a 5-centimeter ground sampling distance. And of course, you always will have higher accuracy if you are very close to objects than very far away. And the thing I'm going to say right now is basically the GSD, the ground sampling distance, is very related to the output accuracy of your project. So when you think about the main effect of when we talk about accuracy, the main thing is usually the distance to the object. And now, what do we mean by accuracy? In general, we give as a rule of thumb to say that you can achieve something around 2 to 3 times the ground sampling distance in vertical and 1 to 2 ground sampling distance in horizontal. Okay, so let's take an example. If you fly over a field and your camera is looking down, if your images are at 2 centimeters per pixel, so each pixel represents 2 centimeters on the ground, then you can expect an accuracy which is around 4 to 6 centimeters in altitude in average. Now, this is a good rule of thumb, but it has also to be taken with lots of precautions. The first one is that this value that we give, this 2 to 3 times GSD in vertical and 1 to 2 in horizontal, is very relative to many different things, and it's a general average value. So first, it will depend a lot on your camera, on the overlap, on how the images were taken with the flight path, also on the scene you have, on the texture, on the edges, and on the content of your scene. And the accuracy will definitely be worse very close to building edges, on trees, on windows like glass windows, on metallic surfaces, and many other parts where definitely you should not expect such a high accuracy. Another thing maybe to think about is, imagine you would do a flight at midnight. So you would take images exactly at midnight where there is not a single source of light. Of course, all your images will be dark, black, and there will be zero accuracy. There will be nothing. The project will probably not even succeed. If you would have done this project at noon, where you would have nice light conditions, illumination, so on, probably, and your overlap is nice, probably you will obtain something very close to 2 to 3 GSD in vertical and 1 to 2 in horizontal. So this is a bit what this webinar is about. How do you know how can you assess closely what is your accuracy, and when you are in the case where everything goes well, which is basically these values that we give, or in the cases where things don't go well. And also to differentiate, sometimes some problems are going to make the whole project worse, and sometimes it's only small specific areas which will not have the same accuracy as the rest of your project. Now, another thing to consider is also georeferencement. Georeferencement is basically, if you had your model and you place it on Google Earth, for example, how closely does it match to the reality? How close does the positioning of your whole project match to the world? This is what we call global or absolute accuracy. Another term that I'm using very often is local, also relative accuracy. This is more if you measure distances or volumes or within the project and you don't care if it's correctly placed on somewhere on the Earth. So let's talk first on the global accuracy, the absolute accuracy. The global accuracy, so setting your project correctly on the Earth, is not something that can be guessed purely based on images. It's basically, this information comes from another source of information, and usually it's from the GPS, which is on your drone or on your camera. If you have GPS for every images you take, then the accuracy will, the software will use this information to place the model at the right spot. Now, it's very important to distinguish two sources of GPS, of geolocation information that you usually can put in projects. And the two big differences are if you use a consumer grade GPS or a professional RTK GPS. If you are not really sure of which GPS you use, that means probably you're using consumer grade, because professional GPS are usually above $10,000. So you would probably know if you're using one. So if you're not really sure, that means you're using consumer grade GPS. And the problem with consumer grade GPS is that it has a global misalignment versus the Earth. And this global misalignment depends purely or very, very much on the atmospheric conditions and on the constellation of GPS you have, meaning that this value will change every hour probably. And usually how it reflects on a project is that you will get your project shifted somewhere of a value of around like 1 to 5 meters on XYZ randomly every time you do a project. And so if you do 3 times in a row the same area, you will see that it will not perfectly align. It will go a little bit 1 meter on the left, right, bottom, and up. And this is what you have with a consumer GPS. However, you can add ground control points, so another source of information. And if these ground control points are measured with the RTK GPS, so a professional GPS, then this will help the software to set the model in the right location. And if it's at the right location, then basically what I just said above there, this 2 to 3 times GSD in vertical and horizontal, is going to be the global accuracy of your project. However, if you use only purely consumer grade GPS in your whole project, the global accuracy of your project will not be 2 to 3 times, will be more like a shift of 5 meters and 2 to 3 times the accuracy. Another type of project that may happen is if you don't use any geotag and GCP and any information at all, basically purely on images. If you have only images, then the the image content are not able to tell how big the project is. It might be 2 centimeters or 20 kilometers. And for being able to do measurements when we're talking about the accuracy of the measurements, then you need to add some sort of information. And this can be either GCPs or some scale information or some geotags. Also, something to know is when you have very, very small data sets, like let's say 10 images, the consumer grade GPS information that you add in your project, if you don't have that many GPS points, then the software is not able to average nicely. And in the average we do, there might be some slight mistake of the project may be 10% too big or too small. So all your measurements will be 10% too large or too small. Okay, so if I have to summarize all of this slide in what accuracy to expect, basically the accuracy you can expect if everything is done well, the flight plan, the project, everything is nice, is 2 to 3 times the GSD in vertical, 1 in 2 in horizontal. And the placement on the Earth is also corresponding to this value if you have some source of professional GPS information in it. If not, then the measurements will be correct, except that the placement on the Earth will be a few meters wrong. And if your project is extremely small, or you don't even have geotags, then even the scale will not be correct. And for that, you would need definitely to add some GCP or scale, and then you can go back in this general setting. All right, so that was a small introduction on accuracy, so you know what we should try to expect. And in many of the projects, you will get very easily that accuracy without having to do anything. However, sometimes you will have artifacts and the whole project may be totally less accurate. As an example, if you fly at very, very late in the evening, the images are extremely dark, and probably this is really sometimes where you would need really to check the accuracy of the project. And here's in this presentation, I'm now explaining where you should look and what and how you should look for different places about the accuracy. All right, so there are two main things when we talk about the accuracy in the software. The one are global effects, which is usually done because of the first step of the processing, and then you have artifacts which are other source of inaccuracies, which are done in the second and third step of processing. So the global effects is really about geolocation and calibration. And the localized artifacts are mostly issues during the point cloud densification or during the DSM and Orthomosaic generation. Something extremely important is, first, the global effects need to be ensured that they are really good, and possibly they need to be improved before starting to care of the localized effects. Why? Because improving step 1 will always improve step 2 and 3. So, for example, if you do a project and you do step 1 to 3, and then you find out that there was some inaccuracies because of step 1, then probably you need to correct them in step 1, and then it will have to recompute step 2 and 3. So you will lose all the previous work, and it will take some time to regenerate all the results of steps 2 and 3. However, the good news is that it's very, very, very certain that the results of steps 2 and 3 will be much improved versus what you had in the beginning. All right, so now let's first talk on the first type of effect, the global effect, which are usually caused because of calibration and geolocation issues. So what could go wrong? Well, many things, unfortunately. One of the first things is the wrong estimation of camera parameters. So the software during the whole first step is basically trying to estimate the quality, all the parameters to make a geometrical model of the camera to be able to use all the information. And when it's optimizing these parameters, it may happen that the optimization fails and go into a wrong result. And this is something to check in terms of quality, that this will have extremely huge effects on the projects. And these camera parameters are shared within all the images of your project. Another thing to check is if the positioning and the orientation of your images was correctly done. So a little mistake in the positioning may have really, really large effects which are hard to see, but which may be of several meters offset in altitude in some part of the project. There could also be when the software is not even able to estimate the position, then some images will be in uncalibrated mode. And that's usually when you have uncalibrated images, it usually means that something is not going that well. And finally, there could be also geolocation issues. So how to detect these 4 different types of issues? Well, there are two major tools that you should use to assess the quality. One is the quality report, which will go in details just after this slide, and the other one is the ray cloud. In the ray cloud, there's a lot of effects on this. And then I'll mention also a few ways how to improve these issues. All right, so the first, as I mentioned, the first tool that allows you to assess, to give a first assessment on the quality of the calibration is the quality report. So maybe I can show a live example. So this is a project. After step 1 has been processed, here you have access to the quality report. The quality report starts with a few links, help links, with a few summary of the different options you used. And then there's the quality check. By the way, something quite important, I was talking in the first slide about this GSD, the ground sampling distance. Well, here is in the quality report, the value that the software was able to estimate from your data, what is the average ground sampling distance. So here I have 4.3 centimeters, 5.3 centimeters. Okay, so what about the quality check? Okay, the first one, the goal is that all of them are green. If they're green, it doesn't mean that your project is perfect. It just means that at least it was detected that your project is not bad. So you still have to do some additional checks, but at least it gives you, if any of them become orange, then you should go on the help link, which is all the yellow orange dot there, which will redirect you to our support webpage that give you some indication of what to do when this happens. But I'll go quickly over them just to give an idea of what we are trying to measure in terms of accuracy. The first check we do is the number of key points we were able to extract in images. So most of the calibration issues are due to not enough key points matching between images. And to have a lot of matched between all the images in your project, well, this works only if you have first a lot of key points in every image. So this is what the first measurement is doing, is trying to assess how many key points it was able to extract per image. The second one is giving you the number of images the software was able to position. If you have some missing images, well, if it's just a few, very little amount of percentage, normally this has very often zero effect. But if you start to see some larger amount, like 5, 10, 20%, this is a good indication that something went wrong in the project. Maybe the project was too complicated, too many things were moving, you were trying to reconstruct a very difficult data set, like with trees at a very low altitude, or the overlap was not enough. So this is definitely something that should be always green if you care about accuracy. Camera optimization is giving you a tip to know if, when I was talking that the camera parameters can go wrong. Normally, for most of the camera you are using, there will be we will have it already in the database, and it will not move too much away from the number we put in the database. However, if there's a strong difference between the initial and the final focal length, then that's a very strong indication that maybe something went wrong in the calibration, and the software had to change a lot the estimate of the focal length. The matching gives how strong the ties are between images. So this measures many things. It measures how complex the dataset was and also how much overlap. So it's a mix between overlap and complexity of the datasets. And this is a very, very strong indicator to understand if the project is solid, or is really, you can trust the results because all the images have very strong ties between each other, or if you should really be extra careful that time. And finally, the last check is the only one that's able to let you know something about how well it is placed on the Earth. And it's going to be green only if you use ground control points. If you don't have ground control points, then we are not able to let you know, the software is not able to compute, to have a fair assessment, to know if the georeferencement is good or bad. We will totally depend on the data that you input. I'd like also now a little bit more in detail to point out two very, very interesting graphs in the quality report that should be checked most of the time in most of the projects, especially when one or two of the green checks starts to become yellow. There are two checks that are really worth to check. So usually calibration issues, they come from the two main sources of issues during calibration is low overlap and mismatches between images. And the two graphs that can give you a good quite some good information about that is this one, the overlap figure. So if most of the middle of the project is green, is definitely a good sign, meaning that you have quite a high overlap and things should be fine. However, if you see some yellow and some orange to red, this is definitely an indication that because of the low overlap, the software will have less way to verify and to make sure that the accuracy is good there. So you definitely should not expect the same type of accuracy when you've got some orange parts versus than when you have some green parts. Another very, very important figure that when our support team gets a project that they immediately go check is the one which is this one, the key point matches. So this is a top view figure of all the different position of the cameras. And the connection is basically meaning that the software was able to find key points that matches between one image to the other image. And the more connection an image has, and the stronger the connection, that means the darker it is, the more you can trust that the position and then the orientation of this particular image is really well computed. So for a small project, it looked like that. Now let's look at a bigger project. Then this figure would look like that. So you'd see that there's very, very strong matches between all of the images. Something to be very careful, and which happen from time to time depending on the project, is there might be a whole seam between two different blocks of this graph. So you may have very strong connections on the left, then one corridor where you don't see any connection, and then very strong connection on the right. So this can happen, for example, if you do a project and you have a river flowing in the middle of the project, and the river is very large and it's water, then the software will not work on water. So of course, then there is no possibility for the left side of the river and the right side of the river to connect. And there you may have a seam. And if there is a seam, this is what we call blocks, different block of calibration. And the way we try to position the two blocks with respect to each other is only based on the GPS or GCP information. And if the GCP or the GPS is not that reliable, then you may have even some misalignments between these two blocks because the information that is given is not enough. Another type of scenarios where this type of two blocks may happen is, for example, if you had a mountain in between. So you would have a terrain and a mountain happening in the middle of your project. And imagine that the overlap, because of you keep the same altitude and overlap for each of the images. On the low parts, then the overlap will be very good. But if the mountains, let's say it goes up to the drone and go down, then at the place where you have the drone, the top of the mountain, the software will not able to do any connection, any matches, and then you will have a big seam between this graph, and there you need to be careful because you know that there's some mismatches between the two. Sometimes the mismatches just happen because the project was very difficult to match in this very particular area. And something that can be done to improve is to add manual tie points. By adding manual tie points, you're actually making one more connection, but your connection, if it's a manual tie point, will have much more influence than if it's an automatic connection. So just with a few of them, you can really guide the software to reconnect, and there it will automatically, very likely, find more matches by itself. All right, so that was a small apartheid on these two figures that are usually the one that we check every single time in the projects. Now another one that is probably the key figure to watch when you are talking about real accuracy, when you're talking about centimeter accuracy, is the one of ground control points. So there are many ways to think that the software, the results are accurate, but at the end, the only way you can be 100% sure that the results are accurate are by comparing it with another source of information. And another source is usually ground control points, which are measured with very high precision tools, like professional GPS, RTK GPS. Now, and this appears in the when you include ground control points, these ground control points will appear in the project and in the quality report at the end of the quality report as a table, and will give a summary of the different type of error. Now, extremely important, there are two types of ground control points. There's what we call ground control points, the normal ground control points, and there's the checkpoints. And they're very, very different, and it should be very, very careful when you assess the quality of a project. So, okay, let's first talk about ground control points. So if you don't have a RTK drone and you have a normal consumer GPS drone and you do a project, very likely you will have you will need to add some ground control points to be able to correctly place the project. And when you're adding ground control points, the software will then try to match the model, the 3D model, as close as possible to the ground control points. And that means that if you look at this figure and you want to see how well the model was able to match to the ground control points, you should check that these figures and that the sigma, which is basically the deviation of the error, or actually even more important, the RMS error, is below 2 to 3 times the GSD. So it's important to check that. However, it does not mean that your whole project is going to be below that error. Why? Because when you insert GCP, the software will try to fit, to shrink, to push the project as much as possible to go through these GCPs. So of course, the error will be always extremely small. So it's important that this value should be below 2 to 3 GSD, but it doesn't still mean that the quality of your project is below 2 to 3 GSD. The only way, really a fair assessment of this, is by using these checkpoints. So what are checkpoints? Checkpoints are exactly like ground control points, except that in the software, so let's look at this project. In this project, you have 4 ground control points. So this is a ground control point, which somebody inputted the coordinates because it was measured through an external GPS, a professional high-quality GPS. And if you want to be, if you look at this report, you see that, so this is the guided tool that comes with the software, you see that there are 4 GCPs. And the error indeed is below, is very, very small, and is below 3 times the GSD. However, this is not a fair assessment of the accuracy of the project. If you wanted to have a fair assessment, you will need to change this 3D GCP into a checkpoint. Apply, and restart the first step of processing. The big difference between checkpoints and ground control points is checkpoints are not used during the calibration. They are only there to assess the accuracy. So the software is not pushing the model to go be as close as this ground control point, as this checkpoint. It's just using it to fairly assess. So back to the question, how many, always the very interesting question, how many ground control points should you use? We usually say that a fair, for quite a medium-sized project, a fair amount is to use something like 8 ground control points. So you will use 5 of them as ground control points and 3 of them as checkpoints. And the 5 ground control points will have to correctly place the model, and the 3 leftover checkpoints will help to assess the accuracy. So now that I've processed both with ground control point and checkpoints, I can go back to the project, I can look at the table, and I can see now that I have 2 different tables. The table of GCP and the table of checkpoints. And the error in the GCP is indeed in a matter of sub-centimeter. So the software was able to really take the GCP and fit it to it. And when you look at the accuracy of the checkpoints, you can see that the checkpoint is now 4 centimeters, 4 centimeters, 11 centimeters, which is exactly between 2-3 times the ground sampling distance. And this is a very, very fair assessment of the accuracy, of the global accuracy of the project. And the more checkpoints you have, the more certain you can be about the global accuracy of the project. All right. Now I presented the tools which are inside of the quality report to assess the accuracy of the project. But there are many, many other tools, and one of them is the Ray Cloud. And when a project gets processed, there are a few things that we really recommend to do to assess the accuracy of the project. One of them is to check the difference between the geotags and the optimized position. For example, in that project, that's maybe not the best example. In this project, I can see here the difference between the blue dot, which is the GPS, and the green dot, which is the optimized position. If the error, if you don't see really a pattern and you see that all the errors are kind of sometimes to the right, to the left, and so on, that basically means that what you see there is very likely just the error of the GPS. And if it's very close by, it's just the 1 to 2 meters error of the GPS. However, if you see a systematic pattern, like all misaligned, or the arrows between the blue and the red being the blue and the green being much longer, that usually indicates that there's quite some serious issues with either the GPS or the calibration. Another thing to check, a check that we do very often, is in the Ray Cloud, try to look it from the side and see if there is any bending effect happening. This bending effect is usually when there was a miscalibration of the focal length or of the parameters of the camera. So when this bending happens, it's very, very often the case that the calibration parameters of the camera, meaning, no, not this one, in this one, that the camera model, the optimization of the camera model, something wrong happened during this, this process. So this is usually two things that we check, and when you see that there are issues, then usually these type of issues are pretty specific, and we recommend to go in the quality report and to check this little marks there to know where to move next to improve the situation. Another very, very important check that we do every time we have ground control point in the project is we go here in the ray cloud over the ground control points, and we check for several things. So we check if indeed it's the ground control points at the place it is, if the marking was done correctly, so if the clicking was done really on the GCP, if the coordinate system is correct, if the values are correct, if the error is small enough. Another check that we very often do for projects is you select a few images, like for example this one, and you look here on the right at the distribution of the key points. So when you click on an image, you get this image and you see the distribution of the key points. A key for successful project is a homogeneous distribution of the key points in the image. So let's take, for example, an image on the border, like this one. Of course, you will have less key points at some area of the project. And because it's the one, it's an image which is just on the side, so nobody is overlapping this this area. So these are all not just key points; these are matched, validated key points, and these are the one that really matters for the whole accuracy of the project. So because you don't have any matched key points on the side, because hell, there is no other image to match it to, this is a strong indication that probably this image, as it has less support on the whole image to nicely tie it to the whole project, maybe this image is going to be slightly less, you should trust slightly less the accuracy of this part of the project. This could also be an indication that something wrong happened, anything else wrong happened in the project. So, for example, I just discovered there by clicking on this image that this part of the project, the top part of the project, was totally saturated. So there was no useful information because of the sun effect, too much the camera the sun reflected very, very bright colors, and the camera was not able to take that in account. So in this part, if you had only this camera, I wouldn't trust too much information coming from this camera. However, luckily enough, there's enough other images with enough good content there to make sure that everything is calibrated. Something interesting too is to use this slider. Key points are important, but key points that match to a lot of images are much more important than key points that match only 2 images. And this slider allows you to go from matching only 2 images to matching to a lot of images. And you can see the progression. And normally, the overlap should when you do that, you should see key points appearing all over the image quite evenly. The reason why you can see that it goes from the bottom to the top in this particular data set is because this image was really on the side of the project. If you pick an image in the middle of the project, then the highly overlapping points are already well distributed, and this is a very, very good indication that the project is good. So this was for the part of the distribution of key points in the images. And then, and maybe actually one of the most important things to check is click a few points to check the reprojection error. So this I'm going to talk now a bit more in details how to do that. So this is a bit the recipe, and this is what we do in every project where we need to assess the quality of the results. The first part is click in a few interesting parts of the project. So what do we mean by interesting parts? Well, interesting is places where you really want to ensure the accuracy, where you need to trust the results. So these are places where you need to sample some points. Also, when in the project, you see some places which are really noisy and some places which are also missing points, or where the results are not as good as what you would expect, or not as good as other parts of the project. This is definitely parts where you would need to click to have a better understanding of what's happening. Another key things to know when you are clicking is also it should be pretty easy to identify, because this is what we'll do in the visual check. So if it's the middle of the cornfield, I would try to rather check the border of the roads which are next to the cornfields instead of the middle of the corn, because that's going to be pretty tricky to identify. In addition, if the manual type point is not that easy to recognize, then what we usually do is we look slightly around this area, and you will always find a place in the vicinity where you can find something easy to click. So this is what I will show. And for that, you need to click on 2 images, click apply, and then you finally check in all the images on the ray cloud on the right, where is the green cross located? And if it's always pointing to the same object, then that means the calibration at this spot is likely, very likely to be good. If it's not, then we really recommend to use manual type points, to add some more manual type points in this area, and re-optimize and to check again. Very likely this will have solved your problem, but for some reason, if this is still not the case, then you definitely need to check many, many more things in your project, and there may be definitely more problems. So let's see in practice how I would do that. Okay, so let's open my project. Here, let's remove the mesh, and let's display the automatic type points. So these are the automatic type points, so the points that are computed in the first step. You can see that not all the area has the same amount of type points. For example, here, there is very little amount of type points. Why? So let's click. Okay, the reason is because first we're on the side of the border of the project, and also because it's forest, which is much more difficult to match than most of other type of environments. But let's look at this one. Let's look at this part. That's another interesting part. Why are there less key points there? So you would click, and of course, there's nothing much to see. The software is much better than the human eye at recognizing difficult patterns. So this doesn't let us know a lot. So usually what I do there is I look in the vicinity of these points. And for example, okay, I see there this stone. So I will look in another image to the same stone. Okay, that's the stone. And I will add a manual type point like this. Then I will click the same point in the 2 images and click apply. And then I will look in all the other images if the green cross is indeed exactly reprojecting on the same part of the shadow. Maybe that's not the best example, because when you click on a shadow, you better hope that all the images were taken at the same time, because if there's a 20 minutes difference between the images, then the shadow may have moved as the sun is moving during the day. So, okay, that was maybe not the best example to take as a point, except if you know that all the images were taken in a very, very close amount of time. So maybe a better point would have to be chosen is a small, recognized stone that is easy to recognize in the different images. So here, as I can see that all the points are nicely reprojecting on the same part of the images, this gives me a high confidence that this part of the project is very likely to be very strong, even though there's not that many key points that were matched together. Let's check another part. Okay, let's check this one. Okay, I cannot see anything, so you look a bit in the vicinity. You check for something you can easily recognize, for example, this stone. You click here and here. You click on apply. Maybe you zoom a little bit and you look over all the imagery. Okay, everything looks good. So likely here, again, in this area, that gives me an extra confidence that everything went smoothly there. If I had found, for example, a mismatch, and for example, the green cross, which would project like 1 meter away from the stone, then one good way to improve the results is to click to really tell the software where it should have been applying, and then you would click on this button there, which is the re-optimize button. The re-optimize button will take in account both the process, both the manual, all the automatic type points, as well as all the manual type points that you just added there. Okay, so to summarize, how to improve when you detect that something goes wrong. So usually you first have to check that all the points that we mentioned above are good. So that's the GCPs are correctly clicked, that the images have good content and everything like that. As I just mentioned now, the best way to improve is by adding manual type points and to re-optimize to improve the relative accuracy. If you need to improve the absolute accuracy, then we usually recommend to add not only manual type points, but ground control points. This is the one that's going to help you improving your absolute accuracy. Another thing also to check if all of that doesn't work is to select a different processing option. In the calibration, you can choose many different settings, and these settings will have effects. I'm not going to detail all of them now, but they are definitely, that's a place where you should look at. However, when you start seeing mismatches and so on, it's not the best. I mean, you can do manual work, but the goal is not to have to do this manual work all the time. It's usually actually a very good, strong indication that something either in the flight plan or the camera or the lighting conditions or the condition of what you're trying to map, something is not correct. And if you usually have a good flight plan that ensures enough overlap and the project makes sense, then normally you don't have to add any of these manual type points. Everything will be correctly, will be nicely good. And then you just use this manual check to make sure that actually everything went well. Okay, so here I talked about the calibration issues. Oops. So the calibration issues is really the thing extremely important. This one needs to be fixed really every time because they will have huge effects on the final quality of the project. However, once you have the calibration which is good, you may still have artifacts. For example, one artifact that happens here is that you can see that some noisy points were added on the edge of this building. Why? So if you click, you can actually see that the shadow was very dark, and because it was very dark, it was also the image was very noisy and of lower quality. You can see purple edges on the border of the building, and this is something that's usually confuses a lot the point cloud densification. And here you have some extra noise, which is not due to miscalibration, because you can see the green dot is always nicely projecting everywhere on the same spot. This is really a point cloud densification error. Now, what can you do against that when you need to, if you wanted to improve the point cloud? Well, you have basically, let's go back to invitation. You have, okay, something I forgot to talk first is most of the issues in the point cloud are usually caused by miscalibration. For example, you may see double layers of points. When you see double layers of points, like a layer and then on top of it another layer, this is usually meaning that it's another good way to see that there was a miscalibration issue. Or when you have areas which are missing, total areas which are missing, this could be also because of miscalibration. Okay, but this can be solved by basically the whole beginning of the presentation. But there are other type of issues that may happen, and this is the one I was showing now, which is the noisy points around building edges, and also very often on the roads, because the visual content of building edges and roads is much more difficult for the software to interpret to create 3D points. So here are 3 solutions we give to assess and to also improve these type of things. One of them is to use the ray clouds to remove them. So basically, you would go here, you would create a bounding box around your object. You would activate the bounding box. Okay. Now you can look it from the side nicely. You would click on editing the point cloud, and you would delete the points. And this way you just removed the noisy points. Another way to do it is by choosing different options for the processing. So when you're doing the densification, there are also several options. Oops, point cloud there. One of the one that makes a bit more noise on the edges of the building is this multi-scale. So if edges of building is really important to you, you may want to disable this option. We've made great progress in 1.5 on building edges, but otherwise you can also use this semi-global matching, which is also pretty good on building edges, which performs a bit better than our normal algorithm for specific case of building edges. However, this is a third-party plugin from another software editor, and that doesn't come together with the software by default. So that's another way. And then finally, if you have more foreground project or very oblique project, if you have sky in your project, another way to do it is to click on a camera. Oops, I need to go out of this mode. Let's, for example, I click on this camera, and there on the side, you have this little pen tool. If you click on it, you wait a little bit, and then you are able to draw on top of the image. Hop, I just selected the whole thing there. And I click Apply Annotation. If I say yes there, you will see that my whole roof just disappeared. The roof I just selected there with my annotation tool. So that's another way to delete quickly points. And finally, if you're interested in the DSM and the Orthomosaic, you may also have specific issues and noise and artifacts happening in this space. And usually the Orthomosaic issues are caused because of the DSM, and most of the DSM issues are caused because of the point cloud. And the point cloud, most of the issues of the point cloud are due to the calibration. So that's why you have to go really in the other way to improve things. So if you have issues in the DSM Orthomosaic, the most correct things to do usually is to edit point cloud. This will in turn, the point cloud will generate the DSM, and the DSM will improve the Orthomosaic. And you have 2 ways to do it. One is just to improve directly the points, like I just did now. Another tool, which is not very well known, is that when you can also create surface object. And when you create surface objects, this will flatten the DSM and make sure that all the points there will be removed. Instead, it will be a purely planar surface. So if you add a surface on the bottom and then on the top of the building, and then you generate a DSM from these two annotations you just did, you will see that the edge will be perfectly straight, the DSM will be perfectly straight, and the Orthomosaic will not have any artifacts and will also be perfectly straight. A faster way to, or when you have moving objects and so on, then usually it's you can use the mosaic editor, or you can remove some images before starting the generation of the Orthomosaic and the DSM. All right. So these are the main tools and different ways that we that are in Pix4Dmapper to be able to assess the quality of the results, especially when you really need high precision accuracy. All right, so the presentation is now over, and I will quickly go over a few questions asked by participants in a little Q&A to see to get a bit more understanding of what people are interested by. All right, so can manual type points improve the relative accuracy? Yes, definitely. The manual type points are, as I said in the presentation, are really helping to add more connection between the images, and connection between the images is what drives most of the accuracy. So but they are not always necessary, and they will not always add the accuracy. For example, here, if I look at this building edge and I click here, if I see that my green cross is always, so maybe let's remove this one. I click on the corner of the building. If I see that my green cross is really well aligned on all the part of the building, adding a manual type point here will not do a lot of effect because it's already right. However, when clicking, sampling a bit the project at different location, and you find that one of them you don't have this perfect alignment, this is definitely a call to action to add a manual type point in this area. Is it recommended to change altitude while flying over mountain to get more key points? This is more related maybe to the first. We have a very interesting slide in the support website that tells over that. It's overlap. I don't find it right there. But about the mountain problem, if you have the same capture rate with the same overlap for a given altitude, and you don't change that, meaning you don't change the altitude or you don't change the capture rates of the images, and you have changes of elevation in the middle, then basically the overlap will not be the same on the top of the mountain than on the bottom of the mountain. And if you have less overlap in the top of the mountain, then you have a bigger likelihood that the project will not be as accurate on the top of the mountain. By having the drone following the altitude of the terrain, you will ensure that the overlap is going to be consistent even without changing the capture rate of the images. And this way you will have the most uniformous overlap in the whole project, and this is a good key to success to have a successful project. So yes, it is definitely recommended to change altitude while flying over mountain. Okay, another question. When using GCPs as checkpoints, do they still need to be marked manually in the ray cloud, or can be left completely unmarked? Very good question. In the current process of the software, we require them to be marked. If they will not be marked, then it would just be an elevation, and we would not be able to compute the horizontal shifts, but only the vertical shifts. So it's not recommended. It's right now mandatory when you use checkpoints to have the checkpoints being marked in at least 2 images. By the way, to the question, in how many images do you need to mark it, which is a very, very interesting question. Let's go, for example, this one. So I said I have 4 GCP, and this one I marked it in how many images? I marked it in 5 images. This is the little thing I have there. So not in all images. And you can see, by the way, that when the ray is orange, that means that the mark that this ray has been marked. If it's green, it means that it hasn't been marked actually. So to know if the marking is enough, we actually have a tool which, well, you have 2 ways to do it. Either you're really good and you watched my ground control point webinar, which basically explains all what these numbers mean, or you can also go here in the option, in the display properties, and show the ellipse error. This basically shows the error of the marking. And if you do it for all of the GCP, if they have all more or less the same error, then it's kind of fine. But you can see that this one has a smaller error than the guy over here. And that's usually a good indication that this one was not clicked enough. And if you would actually click it more, and for example, let's quickly click more of this GCP. Poof. This, as you can see live there, it reduced the inaccuracy due to the misclicking. So by clicking more images, you will reduce this ellipse smaller and smaller. So sometimes it's not worth it. If I would add one more click now to this GCP, it will not improve the accuracy anymore. It's only when this one is really, really large that basically is a good indication that you will need to click a bit more and more images. All right, another question. What is better, few manual type points clicked on many images, or dozens of manual type points clicked in few images? Oh, okay, that goes back to this question. All right, few manual type points clicked on many images, or dozens of manual type points clicked on few images. The goal is normally, if the project is good, I mean, meaning of enough overlap, you really don't have to add any manual type points. So this is only when the project is already in a weird state. So you have already some issues in the project. And there, what's usually the most time consuming is to add manual type points. So probably adding a few manual type points clicked in many images are going to be more useful for the software than a ton of manual type points which are badly clicked. So it's the second one, which I would recommend. So basically, clicking only a few manual type points, by making sure that they are well clicked. But that depends. If your project has really tons of issues in many different places, in that case, then you actually would need to write to click on more manual type points. So it really depends on the case. So, okay, a question, how would you be your strategy for modeling a huge place? 2/3 squared meters. That's not a huge place, 2/3 square meters. I'm not really understand the question. 2 or 3 square kilometers. The question was just the end of the question was after that. So the most important is knowing what type of accuracy you need. You can go always in a project to millimeter accuracy, but to arrive to millimeter accuracy, you will basically have to be very, very close to the object. And the closer you are to the object, the more images you have to take. And then you may end up with millions of images. And that becomes unmanageable, and accessing the accuracy when there's too many images is very complicated. So the goal will really be knowing that we have this 2 to 3 GSD inaccuracy, is to kind of make sure that you fly and you take the images in such a way that the accuracy, that you are in something which is reasonable. And this is really about this GSD mostly. Then I would make sure that given this GSD, that the overlap values are the best in such a way that you don't have to use any of the tools that I showed to actually correct it, because everything will be perfect from the start. And usually something reasonable is to go up to, let's say, 2 to 4,000 images. This is still on the high end of reasonable for doing when you need to assess how many images you need to take. Okay, another question. When removing conveyor belts above sand volumes, there are gaps. Is there a solution to close these gaps? Yes. So that's a very good question. So for example, in the project, let's do it right there. Up. So here, let's say I have a conveyor belt. And if you remove the conveyor belt, so this conveyor belt, and by using this tool, this will basically destroy both the points on the top of the conveyor belt and on the bottom, on the road below, which could be the volume you need to measure. And this is because this tool will select all the points which are below the thing you mark. So how can you do? Well, I would advise to use the bounding box tool that we have there. So this is the bounding box tool. You would shift it there, and you will make sure that on the altitude you would always go slightly, that only the conveyor belt is within the bounding box and not the volume below. So a bit more like that. And when you clip, now you only see the conveyor belt. So that means that when you delete these points, and you remove the clipping box, there you just deleted the points which are on top of the conveyor belt, and you didn't remove any points which are below. All right, is there a way to calculate flight height based on the final scale requirements? Yes, there is. In our support website, we have many articles which are discussing about that. Give you a few formulas and even an Excel sheet where you can enter the camera and the type of flight overlap you're looking for. That will help you to know at which flight light you should fly. We also just added in our capture app we have a capture app for the DJI Phantom. We added in the version that will be released on next Monday, also a way to have the relationship for this between the GSD and the drone altitude. All right, it's been already a bit a longer webinar than planned. Thank you very much all for attending this webinar. I hope it helped you to better understand how to assess accuracy and how to really be sure of the accuracy of the projects that you produce. All the pending questions will still be answered by our support team. And well, thank you very much for attending this webinar. The next one will be on the first week of the next month, which will be again a question and answer webinar without a specific theme. And the next webinar with a specific theme will be happening in 1 month from now. And I can already tell that very likely the theme of the next webinar will be presenting the new features of Pix4Dmapper 1.5 that will be released around that date too. All right, so thank you very much for attending the webinar. Feel free always to go in our forum.pix4d.com and ask questions anytime, or when you have very specific questions to directly contact our support team. All right, have a great day. Thank you all for watching the webinar, and I hope to see you next time. Goodbye.